Hello everyone. Today we are going to see about the addition of two 8-bit numbers using 8085 microprocessor. So what is the logic behind the addition of two 8-bit numbers? So we are going to get two 8-bit data from the memory and we are going to add those two data and store it in the memory. For example, I'm considering the two memory locations, that is 8500 and 8501. So in 8500, I am having the data, that is 8-bit data. Okay. For example, which is 42. And in 8500, I am having another data, which is called some 28. Okay. So 42 and 28, these two data I am going to add. So for that, what you have to do is first you have to clear one register. Supposing if we add these two data, that is two 8-bit data, there is a possibility of getting the 9th bit. So to store this 9th bit, we need a register. So that's why I have assigned a register called C register. So before I am going to clear that register also. So for this, I have used the instruction move immediate C, 0, 0. So move MVI is move immediate C, 0, 0 means the 0 zeros immediately move to the C register, meaning the C register is cleared. Now, I'm going to get the data from the memory location. So for this microprocessor is an accumulator based microprocessor. So meaning that if we want to take a data from the memory, we have to get only through the A register, and also while storing also we have to store the data via the A register. So that's why we have used the instruction LDA. So LDA means load the accumulator with the content of 8500. So what is the content of 8500 means? The content of 8500 is 42, because already we have stored the data 42 in the memory location 8500. So in 8500, I am having 42. So that is loaded in accumulator. So the content of A is 42. Now, again, the second data has also been loaded via the accumulator. So again, what you have to do is, in order to get the second data, first we have to move the first data to some other registers. So here I have taken B register. That is move B, A means the content of A is moved to B. Now the content of B is 42. Now, again, load accumulator 8501 means in the 8501, I'm having the data 28. So load the accumulator with the content of 8501. So the content of 8501 is 28. That is loaded in A register. So now we have got two data. One data is in A register and another data is in the B register. So what is the next step? We need to add the both the data, that is using the instruction add B. So add B means the content of A and the content of B. Both are added and the result is automatically stored in the A register. Now, what is my content of A? It is 28 and the content of B is 42. And the result has to be stored in A register. First, we need to add these two data. Now, the content of A is 28. So how we'll write it in the hexadecimal format? That is, you have to write this 28 hex. Okay, so this in the binary format. So 2 can be written as 0, 0, 1, 0, and 8 can be written as 1, 0, 0, 0. And in B, I'm having 42. This is also a hexadecimal number. So this 4 can be written as 0, 1, 0, 0, and 2 can be written as 0, 0, 1, 0. So when you add 0 plus 0 becomes 0, 0 plus 1 is 1, again 0 plus 0 is 0, 1 plus 0 is 1. Again 0, 1, 1, 0. Now the value is 0, 1, 1, 0, 1, 0, 1, 0. So 0, 1, 1, 0 is 6 and 1, 0, 1, 0 is 8. So the result is 6A. See, listen, after adding these two 8-bit numbers, the result is also an 8-bit number. So here we don't get any 9th bit. Only if we get the 9th bit, carry flag will be affected. So after any arithmetic operation, you have to check for carry. If there is no carry, just store the result. Or else, if there is any carry, that is, if we add these two 8-bit numbers, if there is any carry occurs, that is, if any 9th bit occurs, then you have to increment a C register. So in our example, 28 and 42 are added and the result is 6A. Here, there is no 9th bit. So there is no carry. So if there is no carry, it just jumps to the loop. So this is loop 1. Okay, in the loop 1, what is the instruction is just store the accumulator in 8502. So STA stands for store accumulator. Now, what is the content of accumulator? It is 6A. So this 6A is stored in 8502. So this is my result. And move A, C. So here, since there is no carry, the C flag, that is the carry flag is 0. So the C register is 0. So here, my C register has 0, 0. That is moved to A register. So A is equal to 0, 0. And store accumulator 8503 means this 0, 0 is stored in 8503, which is my carry. That is in 8502, my result is stored. My result is 6A and there is no carry. So the carry is stored in 8503, which is 0, 0. So that's all about the addition of two 8-bit numbers using 8085.